Hello everyone. In this video we're going to be taking a look at power and energy versus time graphs. So we're going to start this video by jumping straight into an example where we take a look at an energy versus time graph of a small electric car. This electric car has a power output of 10 kilowatts or 10,000 watts, and it's going to start at rest and it's going to accelerate down a straight section of track. Using the information, we're going to graph this car's kinetic energy as a function of time on these axes to the right. So we know that the power output is essentially how quickly the object is changing its energy. So 10 kilowatts or 10,000 watts means that the car is gaining 10,000 joules of energy every second. So in order to plot that, we just want to show that this car increases its energy by 10,000 units or 10,000 joules every unit of time, every second. So we're going to go ahead and scale these axes so that every box on the horizontal axis is 1 second, and every box on the vertical axis is going to be 5,000 joules, but we're going to label every 2 boxes. So every 2 boxes is 10,000 joules of energy. Plotting all of our points, showing that we're increasing the energy by 10,000 every single second, we should get a straight line graph whose slope is equal to 10,000 joules every second. Since the slope of this graph is equal to 10,000 joules every second, the slope is essentially telling us the power generated by the object. The slope is the change in energy over time, therefore the slope of an energy time graph equals power. We'll take a look at another example where we're given an energy versus time graph for a cart that is slowing down. So the cart's initially traveling at 4 meters per second, it applies its brakes, and the energy as a function of time is plotted on the graph. So we see that the energy is decreasing, or the kinetic energy is decreasing over time. Our goal here is going to be to calculate the cart's velocity at the time t equals 0.4 seconds. So we know at this point in time on the graph, the cart has an energy of 2 joules. So what we want to do is we want to set that energy equal to the kinetic energy equation. That's going to allow us to solve for the velocity of the cart at that point in time. So taking this equation and rearranging for the speed of the cart, we'll get that the speed of the cart at that time is going to be equal to the square root of 2 times the energy at that time divided by the mass. Plugging in the numbers, we're going to get that the velocity is going to be the square root of 8 meters per second, and then that equals 2.83 meters per second. Now, since we took a square root, it could be in the positive direction or the minus direction, forwards or backwards, but the problem clearly states that the cart is moving forward. So the speed would be 2.83 meters per second, and the velocity would be 2.83 meters per second in the forward direction. So even though the problem doesn't ask for it, we do want to use the information that we presented in the previous slides, where the slope of this graph is actually going to give us the power output of the car's brakes while we're slowing down. So to do that, we just want to use the change in energy over time, or the slope of the graph. So we'll get the change of 4 joules over a duration of 0.8 seconds. That tells us that the car's braking power is around 5 watts. And that's going to be it on this problem introducing power and energy versus time graphs. Thanks for tuning in, and I'll see you next time.